R and R squared values. This is just a handout which I've made for my class, which we're going to talk through. This is used in particular, hopefully we've already covered that if you've got a scatter plot and it looks something like this, so it's going straight up, right? There is a correlation to it, but is this strong or is this moderate? And if you're only doing it by eye, if you said either one of those, you're probably going to get it marked correct. But if we need to know exactly, this is where we need to find an R value. So an R value, its proper name is Pearson's product moment correlation coefficient, and it tells us the strength of the correlation. We're going to calculate this value on the calculator a little bit later on, but what we do is we find out where it fits. So if we did this and found out the number was 0.6852, we look for where that number is. That fits in this gap here between 0.75 and 0.5, so it will be a moderate positive linear relationship or moderate positive linear correlation. We've also got an R squared value, which tells us the amount of the variation in it tells you the amount of the variation in the response variable that can be attributed to the explanatory variable. So we'll calculate R squared as well, but if we calculate R squared and find out is 0.7925, we take this number, the decimal point is going to end up in there, and we have 79.25% of the variation in, and you use the response variable's name. Don't write the response variable. If the response variable is height, say height. It can be explained by the variation in the explanatory variable. And again, write the term. If the explanatory was age, put age in. The last part of this sentence is not always required, but if 79.25% was explained by this, the other 20.75% is due to other factors. This sentence becomes really, really important. Know that sentence, know how to fill the gaps in to tell us what the R value tells us. What we're going to do now is we're going to calculate, the R squared value. We're going to calculate the R value, and we're going to calculate the R squared value on the calculator. So what we've got to do, we've got to put a table in. So our table goes in our lists and spreadsheets page. Make sure you do give it a heading. Use more than one letter so it doesn't get confused between the column heading and the thing you do, and don't put any spaces in. So we said the two things we'll be looking at will be age, and we'll be looking at height. We need the heading so that we can go further. Now, I'm just going to make a few numbers up here. If we had someone who was 4 and 52 centimeters tall, enter them like that. I'm just going to pause it, make up the rest of the numbers, because I think everyone's capable of doing that themselves. So what I've now done is I've just made up some age and heights. They're not precise. I haven't actually measured them. They're just numbers to make this work. I've put the columns in. I've made sure that everyone's age and height matches up. If you don't have one of the numbers, don't put both in, because if I put an age here and not a height, it's going to confuse the calculator. It won't be able to work it out. And we want to calculate the R and R squared values. So we go to menu, go to statistics, go to stat calculations, and we're going to go to linear regression. Now, in our current study design, we need A plus BX. So that's what we're going to use for year 11 general maths. It now gives you an X list and a Y list. We remember with scatter plots, our X list is our X variable, which is our explanatory variable. So in this case, we had age and height. I'm going to say that someone's age will influence what their height is. So the height will change in response to the age. So the age is the explanatory variable, which means our height was our response variable. Then we don't need to change anything else. We can say we want it to start in, say, column D instead of column E, or column C just to put it closer, but that can start anywhere. And we end up with this bunch of things filled in. If we need to go over a few things, A plus BX tells us the gradient, tells us the y-intercept, things that you may need to know. Sorry, I got that backwards. It tells you the y-intercept and it tells you the gradient. There is your R squared value. So if we need to find R squared, 0.779144. So if we need the sentence, 77.91% of the variation in height can be attributed to the variation in age. And below that is your R squared value, 0.8826. So we go back to our table and find out where 0.8826 fitted. And our 0.8826 fitted between 0.75 and 1. So it tells us we had a strong positive linear relationship. The only other thing we can do, if we haven't done it on the calculator, if we know the R value and we want to find R squared, square the R value. So if we go back to our calculator for a moment, And in coming back to the calculator, I realised I didn't round off completely because it didn't round off properly because the number after the 6 was a 9, so it should have been 0.8827. But if I square this number, it gives me 0.7791. So the R value squared, 0.7791. Go back to this, R squared, 0.7791. So if you know the R value and you want R squared, just square it.